Good day everyone, welcome back to our YouTube channel, and this video will cover week 2 of quarter 3. For week 2, we have MELCs 22 and 23. Illustrates the need for an axiomatic structure of a mathematical system in general. And in geometry in particular, we have defined terms, undefined terms, postulates, and theorems. For our objectives, first, identify the defined and undefined terms in geometry. Second, understand each of the given defined and undefined terms and its usefulness. Third, value accumulated knowledge as means of new understanding. Now let's proceed to undefined terms. This is the most fundamental concepts in geometry that do not have precise definitions, but we understand their meanings intuitively. Examples: point, line, and plane. Now let's talk about point. A point can be represented by a dot. The size that you make the dot is not important because a point has no size. Make it just large enough to see. A point is named by using an uppercase letter or black letter. Examples. So this figure would be called point P. Another example. This figure would be called point X. So look at the pictures. So here are some examples of a point. Next, let's talk about line. A line is a set of points that extends infinitely into opposite directions. So what does infinitely mean? Infinitely mean never ending or goes on forever. Alright? Example, look at the figure. Why does it have arrows on both ends? Alright, to show that it extends infinitely in both or opposite directions. And to further understand, line is an infinite set of adjacent points. Example, this curved line and this straight line. So here are some real-life examples of a line. Now let's proceed to naming a line. We have two ways. So use the names of any 2 points on the line. Example, I have here point P and point X. So what names can we give to this line? Okay, we have line PX or line XP. So paano ba natin siya isusulat? So, kung mapapansin nyo dito, we have a line on top of the letter. So, wag lang natin kakalimutan yung arrow on both ends. Alright, so we have line PX and line XP. Alright, we have our second way. Use a lowercase cursive letter located near one of the arrows. Example. So what name can we give to this line? Very good. So line M. So paano natin siya isusulat? Okay. So again, a small letter, and don't forget the line with 2 arrows on both ends. Okay? We're done discussing point and a line. Now let's proceed to a plane. What do you mean by a plane? A plane can be drawn or represented by a 4-sided figure known as a parallelogram. So where can we see plane? Alright, very good. Here are some examples. Now naming a plane. A plane can be named by a single uppercase black letter written near a corner of the plane. Example. So what is the name of this plane? Alright, plane Q, or we can write it like this. So why can't it be called plane R or N? Very good. R and N are names of points. Defined terms. It names the term being defined. It places the term into a set of categories. It distinguishes itself from other terms in that category without providing unnecessary facts. It is reversible. The examples are collinear point, coplanar point, and subsets of a line. What is collinear points? A collinear set of points is a set of points all of which lie on the same straight line. Look at the illustration. So points A, B, C, and D are collinear, while points A, E, and C are not collinear. So observe the given illustration. So we have here point A, B, and C are collinear because again the points lie on the same straight line. How about coplanar points? Coplanar points are points that lie on the same plane. I have here an example. So points A, B, and C are coplanar. Again, because the points lie on the same plane. Next, subsets of line. We have line segment or segment and ray. So what do we mean by line segment? It's a part of a line that is bounded by two distinct endpoints and contains every point on the line that is between its endpoints. How about ray? A part of a line that has a fixed starting point but no endpoint. It can extend infinitely in one direction. Now let's see the difference between a line segment and ray. So I have here an example of a line segment and a ray. Always remember that a line segment is named using its endpoints. The symbol for a line segment is the letter name of each of the endpoints with a line over the top. So I have here a line segment AB. Next, for ray, a ray is named using its endpoint first and then any other point on the ray. So I have here ray EF and ray BC. Next, angle. Angle is the figure formed by two rays or line segments called the sides of the angle, sharing a common endpoint called the vertex of the angle. Always remember when the line segments or rays intersect at one point, they form angle. Alright? Now let's discover angle pair relationships. First, complementary angles are two angles that together make a right angle. The measures of the two angles must add up to 90 degrees. Let's take an example. I have here angle ABD and angle CBD. Now, the measure of angle ABD is 30 degrees plus the measure of angle CBD is 60 degrees for the total of 90 degrees. So, therefore, angle ABD and angle CBD are complementary angles. We have two angles whose sum is 90 degrees. Next, supplementary angles are two angles that together form one half of a complete rotation or a straight line. The measures of two supplementary angles must add up to 180 when added together. Example, measure of angle RPD plus measure of angle QPT equals 180 degrees. So, 145 plus 35 degrees equals 180. So, therefore, angle RPD and angle QPD are supplementary angles. Another example. Measure of angle R is 150 degrees plus measure of angle P is 30 degrees. So 150 plus 30 degrees equals 180 degrees. So therefore, angle R and angle P are supplementary angles. Angle R is a supplement to angle P, and angle P is a supplement to angle R. Okay, how about adjacent angles? Adjacent angles are angles meeting at a common vertex or corner and sharing a common side. Here is the illustration. Adjacent angles are side by side and share a common rate. These are examples of adjacent angles. While these angles are not adjacent. Next linear pair are two adjacent angles and whose non-common sides are opposite rays. Linear pair postulate states that linear pair of angles are supplementary. So, in the figure, angle RPD and angle QPD are linear pair of angles and supplementary. Okay, always remember this. Linear pair of angles are adjacent and supplementary. Next, vertical angles. Vertical angles are two non-adjacent angles formed by two intersecting lines. To further understand, look at the figure. Line AB and line CD are two intersecting lines. The vertical angles are angle ABC and angle BPD and angle APD and angle BPC. Alright? Always remember this. Vertical angles theorem. Vertical angles are always congruent. So we have here a vertical angle 30 degrees and 30 degrees. And another vertical angle 150 degrees and 150 degrees. So here are other defined terms. Perpendicular lines. Two lines are perpendicular if and only if they intersect and form right angles. Perpendicular bisector. Bisects a line, a ray, a segment, or a plane at its midpoint perpendicularly. Next, parallel lines are coplanar lines that do not intersect. Next, skew lines, non-coplanar lines. Transversal is a line that intersects two or more coplanar lines at two distinct points. Alternate interior angles. Two non-adjacent interior angles on opposite sides of the transversal. Next, alternate exterior angles. Two non-adjacent exterior angles on opposite sides of the transversal. Corresponding angles. Two non-adjacent angles, one interior and one exterior on the same side of the transversal. That's all for this video. Thank you so much for listening and have a good one.